Namaste and welcome to Try for Learn. It's me, Rupesh Singh Bohra. And theorem number 1. Parallelograms standing on the same base and between the same parallel lines are equal in area. This theorem can be proved by using different methods. Here, I'm going to prove this theorem by using theoretical method. Let's see this method. Okay, first of all, here for this theoretical proof, you need to draw two parallelograms standing on the same base and between the same parallel lines. Here you see parallelogram ABCD, on the base AV is drawn, parallelogram ABCD is drawn. Look at this, parallelogram ABCD is drawn. On the same base AV, you need to draw another parallelogram, that is ABEF, on the same base AV, another parallelogram ABEF is drawn. How can we prove these two parallelograms are equal in area? For that purpose, here in the figure, here are two triangles. One is ADF and another triangle is BEC. If you are able to prove these two triangles are equal in area, then we can add this middle trapezium ABED on both triangles, and then we can get parallelogram ABCD and another parallelogram ABEF having same area. Okay, let's continue our solution. Okay, first of all, write down what is given here. Parallelograms ABCD and another parallelogram ABEF are standing on the same base AB, on the same base AB, and between the same parallel lines AB and FC. And to prove area of parallelogram ABEF, this ABEF is equal with area of parallelogram ABCD. This is our target. For this, here we are going to write its proof. Okay, first statement. We're going to take two triangles. As I told you already, we need to prove these two triangles are equal. First of all, for that purpose, in triangle AFD and triangle BEC. Okay, what do you see? These two angles, in the figure, AFD angle is equal with BEC. These two angles are equal because AF parallel to BE, so that these two angles are corresponding, so their area is equal. So the reason is being AF parallel to BE being corresponding angles. This is the reason behind that. Okay, another statement. Also, another angle ADF is equal with angle BCE because AD parallel to BC, so that they are also corresponding angles. So the reason is, being AD parallel to BC being corresponding angles. Okay, also you see here these sides, side AD is equals to side BC because these are the opposite sides of parallelogram. Opposite sides of parallelogram are equal, so that these two sides are equal. So the reason is being opposite sides of parallelogram. From these three statements, you see here, angle side axiom, this is going to exist here, so that these two triangles are congruent to each other. So here is written that triangle AFD is congruent with triangle BEC because of this axiom angle side. Okay, by this axiom we can say that these two triangles are congruent to each other. If these two triangles are congruent to each other, by the property of congruence of triangles, we can say that their area should be equal. So in statement 2, area of triangle AFD is equals to area of triangle BEC. Okay, we can see this from this animation also for your concept. You see here, this angle equal and that angle equal, this side equal, and this triangle, that triangle is equal with this triangle. if you do this back, again this will be exactly same. You know, look at this. Yeah, these are equal. This is just for concept. Okay, now let's move ahead. So that these two triangles are equal, the reason is being congruent triangles. Okay, here you see these two triangles are equal. If we add this quadrilateral ABED on this triangle ADF, then we can get here parallelogram ABEF, right? In the same way, if we add the same quadrilateral ABED on this another triangle BCE, then we can get here another parallelogram ABCD. It means these two parallelograms are equal in area from this statement. So that there we can write triangle AFD plus quadrilateral ABED is equals to triangle BEC plus quadrilateral ABED. Its reason, adding the same quadrilateral ABED to the both sides. If from statement 3, if you add these both, you know, triangle and quadrilateral, we can get this parallelogram ABEF, and if we add this same quadrilateral on this another triangle, we can get this another parallelogram ABCD. So that parallelogram ABEF is equals to parallelogram ABCD. By whole part axiom, you know, these are the parts of this whole parallelogram ABEF, and this, you know, another, this triangle and this quadrilateral are the parts of this whole parallelogram ABCD. So that by whole part axiom, these parallelograms are equal, hence proved. Okay, this one is the proof of this theorem. By another alternative method also we can prove this theorem. Alternatively also we can prove this theorem by this method. Okay, let's see. You need to draw two parallelograms on the same base and between the same parallel lines. Here you see on the same base AB, parallelograms ABEF and another parallelogram ABCD are drawn. Okay, after drawing these two parallelograms, here you need to write what is given here. You know, you need to write the same thing. You know, parallelograms ABCD and ABEF are on the same base and between the same parallel lines AB and DE. This is region what is given there, that is same here. And to prove area of parallelogram ABCD equals to area of parallelogram ABEF. Construction. You know, to prove this, here we need to construct CN perpendicular to, you know, this CN perpendicular to AB. Okay, so that this CN becomes height of parallelogram ABEF and another parallelogram ABCD. Statement. You know, first one, area of parallelogram ABCD equals to, you know, area of parallelogram base into height, so that base AB and height is CN. So AB into CN. Reason is area of parallelogram equals to base into height. Okay. And now next one, in the same way, area of parallelogram ABEF also base into height. So base is AB and height is CN. Okay. So reason is same as this first. Okay. From statement first and second, you see here area of parallelogram ABCD is AB into CN. Also from this second statement, area of parallelogram ABEF is also AB into CN. So from this one, you see here AB into CN and AB into CN same, so that area of these two parallelograms is equal in this statement 3. So from statement 1 and 2, this theorem is proved.